So we're going to start looking at data on graphs and charts, and we're going to start trying to find certain types of values, like the mean, median, mode, and range, things that hopefully you've dabbled in a little bit. And they kind of gather the data and they just give you different information. But before we're even ready to talk about finding the mean or finding the mode and all those different types of data measurements, what we're going to do is we're going to look at different charts and graphs and make sure that we can interpret what the values even are before we try and organize that data. So if you look at just what we're looking at here, 1, 2, 3, 4, and 5, you have 5 totally different representations of data. They're all telling you something, but we need to understand what it's actually telling us before we can do something with it. So on the front of this, we're just going to rewrite the values as a list of numbers. We're just going to interpret the data. We're not going to do anything with it. We're just going to say, what is this telling me? So when I look at number 1, it's representing hours slept, okay, and each dot represents a different person, basically. And so if you count up how many dots there are, that's kind of how many people are being surveyed here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different people being surveyed. So some people might interpret this as 7 times 4, so this is 28 hours or something like that. And that's not what it's saying. They surveyed how many hours of sleep people get, and one person said 4. 2 people said they get 6 hours of sleep a night. 4 people said they got 7, so on and so forth. So that's how we interpret these dots. Each one is kind of one piece of data, one person. So if I'm just going to rewrite all of these, I have 1, 4. I'm just going to make a list of all my data. I've got 2 6s, so I'm going to write 6 and 6. There was 4 people that said 7 hours, so I need to represent all 4 of them. 1 person who said 8, and 2 people who said 9. Okay, so for a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people total, and they've all given different information. Now I can start to organize this data. I can find the average amount of sleep. I could find what's the range, which is the distance from the smallest to the largest, all those different types of things. Now that I've interpreted this and I know what all the values are, I can do stuff with it. So that's what we'll practice on the back of this worksheet. Right now I just want to make sure that when you look at this graph and this graph and this graph and these weird things, that you can actually interpret the data for what it is and then go organize it, go do something with it later. So number 2, okay, we got a bar graph here, and each one of these is a separate person. So this isn't saying there's one person and then here there's 2 people and here there's 3 people. Just instead of writing a name like this is Tom and this is Bob and this is Sally, it's just person 1, 2, 3, 4, 5. So there's 9 people. This is person number 7 and this is person number 9. So these numbers are just telling you each one of these is a different person. And then here are their ages. So person number 1, their age is between 12 and 14, so that'd be 13. Person number 2 is 22 years old. Person number 3, so on and so forth. Okay, so this is not telling you there's 3 people here and 4 people here. This is just 9 different people. So we could just write out this data, but let's try and do it from smallest to largest. Let's try and do it from smallest to largest, because as we start to do some different calculations, we almost always want the order from least to greatest. So the least is going to be the smallest bar I see here, which happens to be person number 1, which is right here. So they're between 12 and 14, so I'm going to call them 13. And I'm going to put a little X on it just so I know that I've already taken care of that bar. So then as I look across this data, the next one, as I go from least to greatest, looks to be this one right here, and that is right on the 14. Another thing you could do is just cross out the person number. So I've done person 1 and 8. The next value, if I'm going up in order, would be this one, person number 3. They're between 14 and 16, so that's 15. And the next ones, I've got 2 of them right here, person 4 and person 5, both with 16s. So I need to list 16 twice. And let's see. Person number 7 and 9 would come next because they're both sitting right here at 17. And then the last two, person 6 is at 19, and person 2 is at 22. So now I have a list of my data, and I can start to organize it with the mean, the median, the mode, and the range. Okay, but I've got to interpret this graph first. So there's all the data. Let's look at number 3. This is going to be pretty similar. The bottom, I've got the years, and then I've got the number of, this is laureates, but even if you don't know what that means, it doesn't really matter. Okay, every single year there's a different number of these things, whatever they are. But we can interpret it. So in 2001, this is a year, there were 15. In 2002, there were 13. So each one of these just represents a different year. When I organize this data, I really don't need the years anymore. I just want to know how many times there were 9, how many times there were 11. So I'm going to try and do this from least to greatest again. So the smallest one is right here, so that's 2006. I'm going to circle it and cross this out so I know that I've already dealt with it. And that's going to be 9. So there were 9 of these Nobel laureates. You can look that up if you're curious what it is, but it really doesn't matter. But there's 9 of them in this year. As I move up the graph and I look at the data, I've got 2 of them here, 2003, 2010. There was 11, so I need to represent it twice because there's 2 11s. I've got 3 12s, 2004, 7, and 8. So 12, 12, 12. I've got 3 13s. And my last one is 15. And there's all my data. So if I wanted to say, well, what's the average number of laureates? Well, I could find the average of these, the mean. I could add them all up and divide by how many I have. Or what's the range? Or what's the median? Or what's the mode? Which one happens the most? Okay, now that I've got them ordered, I can figure that out. All right, the last two now are definitely a little goofy, so we want to make sure we understand these two because they kind of look the same. This is called a frequency chart, and this is called a stem and leaf plot, and we got to be able to handle both of them. So when we look at number 4, you've got the stem and you've got the leaf. Okay, and there's always a key. And the key is most important because these can be written exactly the same, and if the key changes, then these numbers actually mean something else. So the key is telling you that whatever's on the stem, that's right here, and whatever on the other side of this slash, that's the leaf. And so if I had a 1 and a 7, that represents 17,000. So for instance, I've got this 3 and I've got this 6. So if I have a 3/6, that's 36,000. Now, a lot of people think that, okay, I've got this, so it goes 36,600 or something like that. Every leaf represents a different value. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 different values here. So I'm going to have 9 numbers in my list. Each one of these leaves represents a different value. So if I'm going from least to greatest, I'm going to start up here. So if I have a 0, that means there's a 0 in this spot. So instead of 17,000, if there was a 0 here, it'd be 7,000. So in this case, if this was a 1, it'd be 19,000. It's a 0, so this is 9,000. Okay, so this first number is 9,000. So the stems themselves don't represent numbers. It's each one of the leaves that actually represents a number. If you had a 1 and you had nothing left to it, nothing next to it, then that wouldn't represent a value. Okay, the stem is just there to help you create the number, but the actual values are represented here by the leaves. So these are all going to be something in the teens, 12,000 and 17,000, each one of them their own number. So the 1 and the 2 is going to give me 12,000. The 1 and the 7 is going to give me 17,000. Just like here, here's my key. 1 and 7 make 17,000. But there's 3 of them. So I need 3 17,000s in my list. Okay, I did those. Now I've got 24,000. I've got 2 of them. Okay, this is 24,000. This is 24,000. And then I've got a 36,000 and another 36,000. So that one's not so fun to write out because of all the thousands. But this key can change. So this key could have said 1/7 equals just 17. So then this would have been 36 and 24 and 12. Or this 1 and 7 could have said 1,700,000, and then this would be 3,600,000 and 2,400,000 or whatever. Okay, so this key is going to tell you how to interpret these numbers. So that's the most important part on those. So let's slide down number 5 now. So notice there's no key because this is not read the same way. This is not 42 and 52 and 62 and 75. This is called a frequency chart, and the frequency is telling you how many times this happened. So we're talking about the games in the World Series. So how many times were there 4 games played in a World Series? Twice. How many times were there 5 games played? Twice. There were 6 games played 2 times. 7 games played 5 times. All right, so we're actually not going to use these numbers when we write something down. We're going to be writing these numbers. I'm going to be writing 4s and 5s and 6s and 7s, and the frequency means how many times. So 4 games happened twice. So one year there was 4, and then another year there was 4. 4 and 4. There were 5 games twice, so I need 2 5s. There were 6 games twice, so there were 2 6s. And 7 games happened 5 times, so I need 5 7s. 1, 2, 3, 4, 5. So there's all my data. So if you want to know how many numbers you should have, you got to add these up. So 5, 6, 7, 8, 9, 10, 11. I should have 11 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've got them all there. All right. So this was going to act a little bit differently. They're actually pretty easy because you just write this number down this many times. So once you understand it, super easy to interpret. The stem and the leaf is the one that's going to give you the most problems to start out with because it's just really goofy. And to be honest, you hardly ever see this stuff, but it may show up on something like your SAT one day. So you're not going to deal with this kind of on everyday life. I mean, you're really not going to, if I'm being honest. But you could see this on a standardized test, and you want to make sure you're ready for it. So we want to make sure we can interpret this data and then do something with it. All right, so on the back side now we're going to practice actually doing something with this data.